In this video, we are going to talk about the welfare effects of price ceilings. First, we need to understand what a price ceiling is. So a price ceiling is a maximum allowable price. So we can think of it as a law in place that says the price cannot exceed this amount. We're going to work through an example. So let's imagine the demand and supply curves in the market for ginseng are given by the following. Quantity demanded equals 30 minus 0.5 p, and quantity supplied equals 0.5p minus 6, where in this case p stands for price and q is quantity. If we were to graph these demand and supply curves, this is what we would get. So we have an upward sloping supply curve that starts at 12, so that's the p-intercept value, and we have a downward sloping demand curve whose p-intercept is 60. Let's now suppose that the government institutes a price ceiling of $30. I'm going to represent this with a horizontal line at 30. I want you to notice from the graph that the equilibrium price is $36, but that price is no longer legal because of the price ceiling. So we have a binding price ceiling. The price is going to sort of be pushed down to 30 because of this law. And this binding price ceiling is going to have several impacts. The first impact of note is that there's going to be excess demand. Now, excess demand is just a fancy way of saying there's a shortage. So we're going to have more units demanded than there are supplied. And we can really easily figure out how large, mathematically, this excess demand is going to be using our demand and supply curves. So at a price of 30, the quantity demanded is 15. So I'm just plugging price of 30 into that demand curve and evaluating it, and I find that 15 units are demanded at a price of 30. So I'm going to label that on my graph using green. Similarly, if we plug that $30 price ceiling into the supply curve, we'll find that the quantity supplied at a price of 30 is 9. I can label that area on my graph as well. So notice that from the math to the graph, we see that these two values, 15 units demanded and 9 units supplied, come from the points where the price ceiling line intersects the demand curve and the supply curve. Now that we know how many units are demanded and how many units are supplied, we can really easily find the size of the excess demand in this market. Excess demand is the difference between the number of units demanded and the number of units supplied, which is 6 in this case. The second impact of this price ceiling is that producers are going to supply less of the good than they did when there was no price control. This is really easy to see from the graph. We can see that when there was no price control, the quantity supplied was 12. That's just coming from the intersection between demand and supply. And now that this policy has been put in place, the quantity supplied is only 9. So 9 is less than 12. The third impact of this price ceiling is that producer surplus is going to decrease. Without the policy, the producer surplus is this gray shaded area. Remember, that's just the region below the equilibrium price of 36 and above the supply curve from 0 to 12 because 12 units are bought and sold. Once the policy is introduced, the producer surplus is going to shrink to this red shaded area. And the reason why this producer surplus is smaller is because fewer units are supplied, 9 instead of 12, and the price is lower, 30 instead of 36. If we wanted to compute the area of this producer surplus, we could just use the formula for a triangle. So the producer surplus under this price ceiling is 1/2 30 minus 12, which is the height of the triangle, times 9, which is the length of the base. Mathematically, that turns out to equal $81. The fourth impact of this policy is that consumer surplus will change, but by how much it changes is going to depend on which consumers purchase those 9 available units. So as our starting point, in the absence of any policy, consumer surplus would be this gray shaded region. It's the area below demand but above the equilibrium price. Now let's consider how consumer surplus might change. In the best case scenario, the 9 units supplied by our producers under the price ceiling are going to be purchased by the consumers with the highest willingness to pay. You can think of those consumers as those on the highest part of the demand curve, where the height of the demand curve is kind of like a proxy for willingness to pay. If that's the case, if the 9 units are demanded by the buyers with the highest willingness to pay, the consumer surplus will be this shaded region. Keep in mind that this is the area below demand and above price from 0 to 9, because we're assuming that those 9 units are purchased by the 9 highest willingness to pay buyers. If we want to actually compute this shaded area algebraically, we need to find a missing value. We need to know in particular what is the price when quantity demanded is equal to 9. To do that, we're just going to sort of harness the power of the demand curve. So I take my demand curve, 30 minus 0.5p, I set it equal to 9. And when I solve this equation, I find that price is 42. Now the answer here should be obvious because it's graphed to scale, but if you were doing this on your own and you did not have a graph that was to scale, you would need to know how to find this value. So finding this missing value just requires setting quantity demanded equal to 9 and solving for the price that makes that true. Okay, once we have this value, p equals 42, then we can compute the area of the consumer surplus. It's got two parts to it. It's a triangle plus a rectangle. In particular, consumer surplus is going to be equal to 1/2 times 60 minus 42, which that's the height of our triangle. I'm going to add a little line in here to make this really clear. So I'm dividing my region into two parts. I'm finding the area of the triangle. It's 1/2 60 minus 42 times 9. And then I'm adding the area of the rectangle. And the rectangle has a height of 42 minus 30 and a base of 9. When you do this computation, you find out that the consumer surplus under this ceiling in the best case scenario is $189. In the worst case scenario, the 9 units are going to be purchased by the consumers with the lowest willingness to pay. So these will be those on the lowest part of the demand curve that's still above the price of 30. So we're not going to sell it to the people all the way down here because they're not willing to pay $30. Instead, we're talking about selling to this group here who are on the lower part of the demand curve. Before we can compute this worst case scenario consumer surplus, we need to determine where these buyers are on the graph specifically. So we know that there are 15 buyers and only 9 units for sale because that's how many units suppliers are willing and able to supply at this price ceiling of $30. So visually what we're doing is I'm putting a dot at 15 here along the demand curve, and I'm going to subtract 9 to figure out how far to the left I need to go to find the consumer surplus area. So 15 minus 9 is 6. What am I doing here? I am determining that in the worst case scenario, these 9 units are going to be sold to buyers between unit 16 and unit 15. So that's 9 buyers. We're not selling to the highest willingness to pay buyers, which are the first 9. Instead, we're selling to the lowest willingness to pay buyers, which are the buyers between 6 and 15. Once we understand this, we can actually fill in the consumer surplus triangle. So the consumer surplus is going to be the shaded area below demand and above price. That language should sound really familiar. With the addition that it is between 6 and 15 units. Right? So it's a triangle, but it's not the triangle like snugged up against the price axis. Instead, we've sort of slid the consumer surplus down, triangle down until it's touching the price ceiling line. And we're doing a few things really carefully. We're making sure that we're still selling 9 units, so we have 9 buyers. And we're making sure that those are the worst case scenario buyers, the buyers on the lowest part of the demand curve. So we have to do a little bit of work. We can't just work from the equilibrium. We can't work from the price axis. We have to sort of work backwards, subtracting 9 from 15 to figure out where the triangle lives in the graph. Once we've done that, we can compute the area of this triangle, but we have to do a tiny bit more work. We need to figure out this missing value so that we can understand the height of the triangle. Now, all of us here know that that missing value is 48, and if we had not drawn this to scale, we would actually have to do the math. What's going on at this purple dot? Well, this is the price at which quantity demanded is 6. So I'm going to set quantity demanded equal to 6. Filling in what I know, I have 30 minus 0.5p equals 6. Solving for p, I get p is 48. Okay, with that work, I'm now able to compute the consumer surplus in the worst case scenario. It's the area of this blue shaded triangle. The triangle has a height of 48 minus 30. You can see the work that we had to do sort of hiding in that equation. And the triangle has a base of 15 minus 6. Again, you can see the work that we did graphically. And 1/2, 48 minus 30 times 15 minus 6 turns out to be equal to 81. The final impact of the price ceiling is that there is going to be deadweight loss associated with it. So let's talk about the best case scenario first. In the best case scenario, the total surplus is going to be the sum of the best case scenario consumer surplus and the producer surplus, which turns out to be $189 plus 81, which is $270. In this case, if we're in the best case scenario, the deadweight loss is this gray shaded region right here. Just so we're clear, this gray shaded region would have been surplus if the market was allowed to be at the equilibrium price of $36. The top half of the gray shaded triangle would be part of consumer surplus, and the bottom half would be part of producer surplus. But because the price ceiling is pushing price down and reducing the amount of units available for sale, we are missing out on some available surplus. How do we compute the area of this deadweight loss triangle? Using our standard 1/2 base times height computation. So the deadweight loss under our price ceiling will be 1/2 times 42 minus 30, which is like the length of the base of this deadweight loss triangle, times the height of the triangle, which is 12 minus 9. If we do this math, we find out that the deadweight loss is $18 in the best case scenario. In the worst case scenario, the total surplus is going to be the sum of the worst case scenario consumer surplus, which is this blue shaded region, and the producer surplus with the price ceiling in place. Mathematically, we get $81 in consumer surplus plus $81 in producer surplus equals $162 in total surplus. To help us visualize the deadweight loss, I'm going to take this blue consumer surplus triangle and I'm going to slide it up the demand curve until it's touching right against the price axis. Once we do that, it becomes a lot easier to see that the deadweight loss is this gray shaded region. Again, this gray shaded region would be part of total surplus if this policy of a $30 price ceiling was not in place. The top half would belong to consumers and the bottom half would be part of producer surplus. How do we compute this deadweight loss? In order to compute this deadweight loss, we need to find the area of the rectangle and add the area of the triangle, and we can do that quite simply. So the rectangle has a height of 42 minus 30 and a base of 9, and the triangle has an area of 1/2 42 minus 30 times 12 minus 9. When we do this computation, ultimately we find that in the worst case scenario, deadweight loss would be $126, which is vastly different from the best case scenario number of $16.